Today we will be building a balloon car. These are the materials you will need. Okay, so first step is to cut holes in the juice box. So I already did this, but you will want to cut one hole in the front and one hole in the center. And then push a straw through the holes you've just cut. Next, you will want to tie a balloon to the mouthpiece of your straw. So just grab a rubber band and tie it a couple times around. Then you will want to cut your axles to be the right length for your car. So these will become the wheels, and you want to cut the straws a little bit shorter than the sticks. Next, to assemble the wheels, put the sticks inside of the straws, and then grab a couple of bottle caps and poke a hole through them, which you can do with a toothpick or scissors. Now repeat these steps to make your second set of wheels. Now you have two sets of wheels for your car. To attach the wheels, just tape the axles to the body of the car. To ensure that your car drives straight, it is best to tape down your straw so that it is in the center. Now your car is complete. To test your car, first blow up the balloon. Then hold onto one end of the straw to trap the air, put the car on one side of the table, and then release.
So, why does this happen? We can explain this interaction with physics concepts like forces.
Simply put, a force is a push or pull on an object that causes it to move. We can draw a force diagram to see what's really happening.
So, first, the balloon car is at rest. And in this force diagram, we have the car, which is this dot, and then we have each arrow representing a force acting on the car, which is just gravity going down and the table pushing up on the car. And those are equal because the car is not moving. Then, when the balloon releases air and the car is moving forward, there is more forces on the car. There's still gravity and the table, which again are equal, but there's a greater force to the right because it's moving to the right, and a little bit of friction from the table to the left. But this arrow is still greater than this arrow, meaning it's moving this way. Then the car begins to slow down, and still the force of the table and the force of gravity are equal, but the force of friction becomes greater than the force of the balloon's air, causing the car to slow down and eventually go back to rest.
Another physics concept we can talk about is energy, specifically potential and kinetic energy.
At the beginning, when the car is at rest and the balloon is full of air, there is a lot of potential energy and no kinetic energy. Then, when the car is in motion, the potential energy begins to turn into kinetic energy, which is caused by the movement of the car. Then, when the car comes to a stop, there is no potential or kinetic energy left over. But because energy is always conserved, that energy had to go somewhere. So, where did it go? Well, you guessed it. It went to thermal energy, which is caused because of the friction from the car on the table. So, yes, now we can see that energy is always conserved.
This also means that the bigger we blow up the balloon, the farther the car will go because more potential energy translates to more kinetic energy and more speed. That's all for this video. Thanks for listening to our lesson on balloon cars, and we hope you learned something new.